AI is being applied right across the process chain from the very first idea all the way to those moments of interaction with final product. So it's a very broad question. I'll probably just narrow on a couple of key changes that we're seeing. First of all, I think what AI can be applied for very frequently is to narrow the target. So if you're working on a challenge which is quite complex, and there could be many different approaches and solutions to that challenge, it's obviously quite a time-consuming process to actually even come up with the different candidates that you want to validate and you want to test for. So AI can be quite a good way of very quickly exploring a space and identifying a few of the best possible candidates that you might want to subject to more rigorous testing using traditional tool chains to really get a deterministic outcome. So that's really the first one, I would say, narrowing the target before validating the best candidates for a solution. And I think the other one is really about increasing of access to, or the increase of access to complex methods, knowledge, and know-how. So we have a technique, that's a system which we like to call ModSim. ModSim means you empower people who are modeling solutions to be able to simulate them almost in the same workflow. So you don't have two separate functional specialisms, one doing the modeling, one doing the simulation. You try to give those computer-aided engineering tools to modelers so that they can already, as they're designing, already iterate fast and check that the designs they're coming up with are going to perform in the way that they want. So what you're trying to do there is just basically make those validation tools and the simulation tools put them on the same desk as the person who's actually coming up with the designs in the first place. And I think that is an illustration of how AI can increase access to complex methods, knowledge, and know-how. I think one of the challenges here is that at the moment, there's just a huge amount of tool chain volatility. So as these techniques and technologies evolve, it seems like there's a new approach that you can take even at the tool chain level every day. So our customers really rely on us to verticalize and focus what those tool chains can do in the context of a particular industrial task. So we take the complexity of constantly having to change and shift the back end, if you will, of how those processes can be deployed away from our customers so that they can focus on getting the job done. And I think toolchain volatility is going to be around for some time, obviously, as these technologies and processes mature out. And we're here for our customers to make sure that they can be applied in the best possible way at any moment in time. So, I mean, again, you hinted it in the question. There's sort of three segments, I would say. There's the stuff that's already here now, that is in operation, people are already using. There's things which are sort of there, but maybe not yet fully adopted. And then there's sort of, the blue ocean of possibility that, is being conceptualized and worked on, but is probably still some way away from full capitalization and full deployment in the field. So I think in terms of what's going on now, one of the things that's been around for a while and is helping people working in design engineering tool chains is to actually maximize the amount of work not done, right? And particularly around, for example, identifying pre-existing solutions to problems that maybe an individual working in an organization doesn't know about. So typically, if you're looking, for example, to find a particular part to do a particular job inside a bigger product context, it's quite possible in some of these big organizations that problem's been solved many times before. And in terms of the ecosystem overall in which that company operates from a supplier perspective, there may be many, many options already available where you don't really need to do a from scratch design. So part of the tool chain that I think is very widely available already today is the ability for those designers and engineers to source pre-existing solutions rapidly and then sort of tailor around the edges if necessary, rather than start from scratch. And that can be incredibly powerful and incredibly useful from a cost perspective. But also, we're seeing those methodologies start to be applied in some new and interesting ways. For example, looking at not only does this part fit, does it mechanically do what it needs to do, but also how reliable is the supplier behind that part in terms of being able to then actually scale up manufacturing when we get there. So you're kind of giving like a future scope to the designer so that they can make right decisions and trade-offs about whether to use a pre-existing part, but then that might be a difficult there might be a difficult supply conditions in manufacturing. So maybe it's worth doing a bit more tailoring on this one. Those kind of trade-offs are typically managed in a linear fashion or have been managed in a linear fashion. And here we're kind of really bringing some of those questions upstream. Another big one is around sustainability. So around 80% of the impact of any product in the market, in the real world, is the result of its design. So if we can help designers be more aware of what their choices are with respect to the sustainability impacts, again, it helps them make those trade-offs. So I've sort of gone from what's here today, around just simple sourcing of parts. Yes, supply chain resilience testing is already available today, and our customers do use it. And then that question around, what's our eco bill with respect to the designs that we choose? That's something that we're working on very, very hard to deliver, and will be coming, I think, very broadly across manufacturing industries because it's such an important topic. Another one that's sort of on the edge, I would say. I mean, when you talk about prototyping and you talk about product design, sometimes you're thinking about just early sketching in terms of coming up with concepts, storyboarding, those kind of things. Those techniques definitely exist today, and they are being rolled out. I mentioned toolchain volatility a moment ago. That's more of the struggle, I think, that these things are rapidly evolving so rapidly that it's hard to pin down exactly which tools, exactly what context. But the ability to come up very quickly with a story, with a narrative about what the intent of a product is clearly helping at that early stage to narrow the target and help people understand what is the benefit of the product that they're building. And the final one that I think, no, actually, the final one on this sort of intermediate layer that I draw attention to is things like spatial computing. So spatial computing is essentially a computing paradigm that gives us the ability to connect what's happening in the real world with what we've understood and modeled in the virtual world. So you can look at something which already exists and then understand its heritage and understand the possibilities of that thing in the context of its use. And spatial computing relies upon AI, obviously, because you need to train these computers to be able to understand the world around them. So I think that's a really interesting field, which is sort of going beyond traditional computer vision and starting to make it more interactive in the context of how people analyze and understand what's going on in real world environment. This can be really useful in validation. So if you're doing validation processes at just pre-production, then there's a lot of back and forth at that point while you're trying to understand what's going wrong in your early prototypes and how you can improve them. So you're looking at a physical prototype and you've got the virtual model in the background and you're looking to decide how to optimize either manufacturing techniques or even the design itself vis-a-vis what you've learned in those early validation prototypes. So that's a use case where we can see spatial computing, where we can see computer vision powered by AI becoming useful in compressing time to market. If we really want to go futuristic though and look at, okay, where do we think this is going in terms of prototyping methodologies, product design methodologies, I think we have to sort of imagine a world where AI is baked into the product itself. So if you are thinking about products which are themselves capable of understanding the environment in which they find themselves in or the situation that they find themselves in and able either to prompt the user to do something, to make a decision, or maybe even make some decisions themselves. The question about how you design that system is quite an interesting one because you're no longer modeling purely deterministic behavior. And so how you build the tool chain to build the intelligent products is a bit meta, but I think it's really the sort of logical conclusion of what we're seeing in terms of the AI revolution, because what we're talking about really is AI being baked into products. And then the question, how do you model those products, is a logical progression from there. And that's obviously all being driven ultimately by silicon. The amount of innovation taking place in silicon and the democratization even of silicon manufacturing. I say democratization broadly and loosely because not everyone's doing it, but the increasing accessibility to silicon manufacturing is obviously increasing the propensity for objects to be smart. And so I think we're going to see that problem become more common from a design engineering perspective as access to AI capable silicon increases as well. 3D Excite, the part of Das System that I'm responsible for, we really focus on commercial innovation. So I'm going to choose to answer the question from the perspective of the go-to-market piece. So, not so much just the upstream, how you come up with a product, but okay, how does that new product get presented into diverse markets and to different people with maybe slightly different needs and wants. One of the very, very key use cases in that environment is actually the process of localization or adaptation in terms of the storytelling or in terms of the presentation of the values and the features and benefits of the product into different markets. So if you're building a product that's designed for export, you may have very different perspectives on aspects of that product's feature set, depending on the market that is currently being targeted. To give you a trivial example, if I'm making a car which has got heated seats, that might be a necessity in Sweden, but it might be a luxury in Milan, right? So depending on where you are in terms of the context, different features might have different benefits or solve different problems for different people. So localization can be quite a time-consuming and difficult task for people who are building those representations of product features in the context of benefits for people at the local level. You'll typically have a broad idea coming from the brand, coming from the product management about what this product does, and that will typically be launched in a big market or a local market or a trial market. And at some point, once you've got the proof, okay, this is going to work, then you go into this process of refinement for localization. It's a very manual process, involves a lot of research, and then a lot of hard work on the back end of that to kind of create all of those individual stories which work in a particular market. And that is a prime territory for AI, we think, because a lot of the narrative, a lot of the contextualization of the product is general knowledge. The information about the product itself is highly specific and obviously owned by the person producing the product. They're the source of truth, if you will, for what that product can do intrinsically, but how it's relevant in a particular market is kind of general. So if we can fuse those two things together, the specificity, the accuracy about the product, and then the general knowledge about what people need in a particular market, particularly a milieu, then I think we can find a really, really interesting synergy between those two ideas. That can be stretched further if you want to sort of take it to its logical conclusion, which is really about hyper-personalization. So, even within a given market, people can have very different needs and wants depending on their life stage, for example, or, maybe even just what they're trying to do from, for example, a mobility perspective. Do I want to go on a long journey or a short one? Products could do different things for different people at different times, depending on their needs. So if you stretch that analogy or that story about localization down to the individual level, you can get into a situation where you're really generating a lot more value for individuals around the same amount of resources that you've expended to produce that article. And that's why we think that, in fact, these topics around how we go to market, how we do commercially innovate, can actually have a sustainability impact as well, because it's all about balancing the level of happiness, the level of customer satisfaction, and therefore the money that they're prepared to pay with the amount of resources that we consume to create that. And we can, if we can achieve a better balance, not only by reducing the impact on the environment, but increasing the value, then I think that's an important contribution to the sustainability equation. Again, a pretty big question, and it's a very critical one. And there are, I would say, some very well-known theses and discussions around the ethics of the use of AI, which are out there, which apply to pretty much all the fields where it could be deployed. Things like bias and how do we make sure that the things that we are assuming about the results of an AI-based suggestion are truly representative and not disadvantaging certain groups of people. There's a whole question about IP security. I mean, ethics is not obviously just about the obvious ones that are sort of immediately obvious from a social perspective, but also how do we maintain the equity of a knowledge-based economy, right? We actually want to encourage and foster real innovation, and really get people's energy behind coming up with better solutions. So we have to look after the intellectual property that results from that process. And I think that's really an obvious one that comes up not only in the artistic field, but also in a product environment where, companies and people who generate these good ideas are keen to protect them. And I think that's something which does have a social impact as well, because as I said, we want to make sure that it's worth investing in coming up with new ideas. It's something, by the way, that I've seen a lot of that this idea of readiness and willingness to invest. Just the last couple of days as I've been here in India, it seems that this economy is really going into a new phase where investment is becoming really is becoming really ubiquitous, and that's a great thing. But you're not going to invest if you're going to lose the possibility to generate a return on that investment over time. So we need to be able to protect that, and that's, I think, a part of the equation. Otherwise, societies won't invest, and then things won't get better over the longer term. I think connected to that, that idea of social benefit is really something a little more fundamental. I hinted at it before. I think we need to be very careful about the difference between truth and narrative. One of the things that these technologies do, which makes them quite unique, is that they sort of work on our own UI, so our own interface. This makes us very fallible in terms of processing the information that they are throwing at us, because we will tend to believe it just because it sounds plausible. And I think this has been covered quite well by Yuval Harari in his new book called Nexus. I'm not an agent for him, by the way, but I just think he does a good job of really exploring this idea about if we have a world where narrative is ubiquitous and all sorts of agents can talk to us in a very compelling and convincing way, one would hope that truth rises to the surface, right? That we all, therefore, as a result, make better decisions. He points out that there's actually a risk that it sinks to the bottom. And that then becomes very problematic from an ethical perspective, because we end up making bad decisions, and those decisions can have significant impact on the lives of many who are dependent on those outcomes. So I think if we're looking at what we do and how we approach it from a values perspective, I like to sort of talk to my organization about our mission being around creating better access to the truth, making truth more accessible, and making it easier to understand, yes, but try to create some connections around, between people around things which actually have some basis in fact and in the real world. And I think that can really help society overall if we're able to amplify and drive conversation and attention to those things, rather than things which are just there to create distraction and then monetize the distraction itself. I think that's probably not so socially beneficial personally. So I think creating access to truth in a powerful way from a narrative perspective, but making that distinction that the intent is to do things which are really fundamental and actually genuinely going to help, and not just tell stories for the sake of telling stories or for some other perhaps less socially beneficial intent. Let's start with, I'll come to the meat of that question in a second, but let's just start with one sort of segue from the previous topic. When you're talking about designers, it's obviously not just a question of the product designer, but the process designer, right? Or the systems designer who's coming up with the overall solution. And I think it's quite important that we try to avoid, we are critical about papering over systematic deficits. What I mean by that is sometimes when you see AI being applied in an organizational context, you get the strong impression that there's a systematic deficit, there's some problem in the way that, for example, information is being managed, or the way some interfaces are working, between systems. And there's a temptation at that point to just make it look okay by putting AI-based connections on top of that, right? I think we need to challenge ourselves to really ask, okay, are we actually solving the problem here, or are we just kind of shielding it from view And when you're talking about a systems design or you're talking about a process end to end, it's important that we go down to the level of really the source of the problem, and then make sure we're fixing the source rather than just sort of pretending that everything's okay on the surface. So that's more about the system and the process, making sure that we're uh, using systematic methods when they're the right ones and not just jumping straight to heuristics because it seems fancy or it might be marginally quicker to get there. Ultimately, those trade-offs I think can be quite damaging. But at the level of the sort of specific design around AI-driven products, I think really you've got one of the main things that we've seen in the last few years as these technologies have been coming in, your governance around the training data, right? So how you are orchestrating the input side of an AI-based workflow or an AI-based algorithm is absolutely key. One of the things that we've seen is that it's actually possible, if you have a good representation of ground truth, you can come up with much better training sets as a result. So you can be sure that your training set is less biased. You can be sure it's more representative because you can take a systematic approach. So even if you're asking a computer to make some analyses, for example, of whether an object in the real world is a specific part or not, you can give the computer a better chance at making that statistical guess if you've trained it really well using great training data. So the governance of training data is important. Likewise, when you're talking about more like the inference side or the application of those algorithms in the context of another use case, how you put guardrails around prompt engineering is clearly important, and how you tailor the interface to those generative functions is also about mapping not only the DNA, as it were, of the product, so it's sort of its classification and its interface definition, but also about the values and purpose of the organization. So what are we trying to say here, right? So yes, we can do this, but to what end? And I think that's very important as well. That as you get to a good interface between products and the people interact with them, for example, that it's not just functions which are being exposed, but the purpose of the company behind. So being able to govern training data and prompt engineering is very important. The other one which I hinted at there is, when we're talking about privacy, for example, the key idea in a privacy-aware system is being able to ask permission to do certain processing on certain data for certain benefit or certain ends. In order to express what the benefit is or what the offer is, if you will, to the person who's going to lease their data to the person who's going to actually generate that benefit, you need to have a really good idea, a very clearly defined interface about what all those data sets are. So to give you a specific example, in the car world, you've got all of these apps and all of these services that are growing up around the vehicles. And all of those services and apps need to interact with the system which is on board of the vehicle, and that involves exchanging data. And some of that data can potentially become privacy critical, right? It's normally a product or an outcome of somebody driving the car around, and therefore that data actually belongs to them. So if you want to ask them or you want to offer them something to improve their experience, you need to be able to say what pieces of data that are coming out of that interface are going to be used in that process. And this is not just for AI, it's also for any kind of digital or virtual augmentation in the real world. And actually governing those interfaces and looking after them properly is important. There are obviously in each industry standards emerging which help in terms of coming up with a common definition of what those interfaces are. And that's useful because it means that it's easier then not only for application developers, but for customers to understand what's being asked of them. If every company asks them for different things, different times, it's difficult for people to get used to those trade-offs. So designers can ensure that AI-driven products are both user-friendly and ethically responsible if they have a really good understanding of what the data interface is on their product. And designing that data face into their product turns out to be critical to be able to provide those user-friendly and privacy-aware interfaces down the track. We hinted at where we see these technologies being most useful and where their power lies so far. And I think the ability for natural language interfaces to play a part in the product development process is part of that democratization and accessibility that I was talking about at the top of this conversation. So if you're thinking about how I can design a scenario in a mobility system, for example, so in the car industry, you might well want to move beyond like just a purely code-based definition or a purely narrative-based definition. To give an example, let's say how I want the car to welcome me, depending on a whole different set of circumstances. So that yesterday there was a bit of a storm here in Mumbai and Pune, and there may be different things that cars should do when it's really heavily raining, for example, than when it's a really hot day. So depending on the circumstances at the time of day, maybe the car is sort of preconditioning if it's really hot, right? And if it's really wet, it might be sort of making sure all the windows are clean and so on as I walk up to it, so that when I get in, it's welcoming. I just made that up. That's not a real use case, but to give you a sense of what I'm talking about. So you might have a really broad range of situations that you want cars to address for end customers. And being able to express what those target scenarios are in a quick and easy way turns out to be linked to the ability for computers to understand voice. So you can kind of specify what those scenarios should be using natural language. So I think that's one area where actually baking artificial intelligence into the tool chain itself can help address some of these emerging areas, which are themselves a function of the arrival of powerful silicon, software-defined products, and ultimately AI. That was a couple of car industry examples there. I mentioned before about computer vision being at the core of this as well. So alongside natural language interfaces, the ability for products to see the world around them becomes pretty important. Not only obviously in areas of autonomy in vehicles, for example, but actually even how you move through the process of manufacturing or into the process of manufacturing. So specifically, I'll give you an example. When you're doing late stage validation, that's typically a process that takes quite a long time to do. It's very expensive to be able to build, a number of prototypes, maybe 1,000, maybe 150, depending on the scale of the organization and the task at hand. And then you're going to run those prototypes for a certain amount of time, 2 months, 3 months, and then you're going to actually come back and see what happened to them. And you're probably going to try and stress test while that's all going on. When you come back and look at them, what you're probably going to start doing is disassemble to a certain extent, right? Either you're going to look at them again analytically, or you're going to start to even like take them apart again to see where problems went wrong. And at that point in time, you really want to be able to refer back to your model, but you're actively working on the physical part. So computer vision can be really useful in compressing the time that those processes take. As you're going through those validation, you're continually aware of, look, here, there's this part, it's got this corrosion problem. Oh, look, there's this part, it's got this problem in terms of the alignment with the part next to it, so we need to change it a little bit there. This part, maybe there was a manufacturing defect on it, so we need to look at the process in that particular case. If, as you go through that validation, you're constantly able to identify the parts quickly, find the problem areas quickly, then that's obviously going to help you get through that process rapidly. So another example from automotive. In healthcare, again, computer vision's obviously very important for understanding symptoms quickly and being able to advise practitioners on what to do next. And, again, how you design those capabilities into products becomes an industrial equipment problem. So how is that actual AI capability, which is on the device itself, going to be made available to people using the device so that it serves the operation that they're currently conducting? So you really have to think about the operational environment of the product you're building and all of the things it's trying to do for the people that use it in order to be able to come up with that ideal synergy between what artificial intelligence is doing at the base layer and how it's being applied in a particular situation. So I think that's a couple of examples there: automotive, healthcare, retail. One of the main areas that we've seen is in customer service. So you've got a lot of information flowing in a customer service environment, either because through techniques of analysis, big data on the front end, for example, of a website or a mobile app, where you're in a self-service environment. In the other context, call centers, people calling in, talking about products, talking about problems they may be facing, their own needs, and using that data to understand better how it fits with the product and with the user's needs, obviously is a key part of the process. So that's something that I think in retail we're seeing a lot of. It becomes very important, therefore, for product manufacturers to be able to provide retailers with the kinds of models that they need in order to make those use cases come to life. So if you're selling a product, you ideally want to be able to represent what that product can do directly to the end customer while you're talking to them. And that's obviously something that we help our customers with, is again providing accessibility to that truth.